Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides even more practice constructing CI estimates for population means using StatCrunch. Let's get started. So first, let's look at an example that we've seen several times before in previous mini lectures, the ages of U.S. presidents. Let's compare the pre-1900 U.S. presidents with the post-1900 U.S. presidents. So we've got 20 who served before 1900, and then we've got 18 in our data file that have served after 1900. You can see the sample mean and standard deviation values listed there on the screen. We want to answer the question by constructing a 90% confidence interval for the mean value of each group. So what we're going to do is make a confidence interval for each of the groups and then compare the confidence intervals. Okay. So we're going to make each CI separately using the same options that we've looked at before, only this time when you're going through the menu options, don't select to sample. Select one sample. There's a very specific reason for that. If you select the to sample option, it's going to create one confidence interval for the difference between the two means. And what we want to do is make a confidence interval on the mean for each group and then compare those two values against one another. So we don't want the two sample option, we want the one sample option, even though we're looking at two different samples. When we put that data into StatCrunch, here's what we get for the pre-1900 group. Here's what we get for the post-1900 group. So looking at the lower and upper limits, they seem to be almost entirely overlapping. So what can we conclude about the age preference for the two groups? Well, what say you? Well, these two confidence limits are almost entirely overlapping. Okay, so because of that considerable overlap, we tend to prefer presidents in the early to mid 50s, both before and after 1900. It's pretty much the same. Let's look at another example involving the arrival time of airplane flights. So 12 arrival times in minutes, randomly selected American Airlines flights from JFK in New York to LAX in Los Angeles are here in the table. An on-time arrival would appear as 0. Early arrivals are listed as negative numbers. So here in the table, we've got the first value, -5. So that means this flight arrived 5 minutes early. This flight arrived 32 minutes early. This arrived 13 minutes early. This flight here arrived 14 minutes late. Okay, we don't see any zeros, so there's no on-time arrivals here in our data set, just early and late arrivals. So with this data, what is the 90% confidence interval of the mean arrival time? Well, there's not that many data points here in the table, so if I wanted to, I could go and just actually manually put them into StatCrunch, just type them in, and I would get this confidence limit out from my results window in StatCrunch. So there's the lower and upper limit, -24 to about a +6. So there's our confidence interval with a 90% confidence level. How good is the on-time performance? Well, look at your confidence interval. What say you? Well, I hope that, again, when you're looking to evaluate the confidence interval, you're looking for that 0 value and where it lies with respect to the confidence interval. So here 0 is actually inside the confidence interval. So therefore, it could potentially be the actual value we're looking for. And so, this is actually looking pretty good. Okay. So on-time arrival is a potential value for, the mean arrival time. And if you look at the data itself, okay, you've got 12 values here, 9 of which are actually early arrivals. So 75% of our sample data are basically coming from early arrivals. So those two combined together, puts us in very good territory. The airline performance is looking really very good. Let's look at one more example problem, this one involving the volumes of brains. So what is the 99% confidence interval for the mean brain volume based on this sample of 10 brain volumes? So this is the 10 different data points there. And then we're asked to assume that the population standard deviation is 125.95. Well, to calculate this problem, how would you proceed? Go ahead and stop the video here and figure this out. Do your best. Come back. We'll see how well you did. Okay, let's check this out. So we know here what the population standard deviation is. It's telling us to assume the value there in the problem statement. So therefore, we want to use the standard normal distribution and calculate a z-score rather than the student t-distribution to calculate a t-score. So enter our values in the StatCrunch, find summary stats. Or we could just, use the actual data itself. But if we want to go with summary option, we're going to need summary stats. So here's our summary stats. So now we can go into StatCrunch and use the menu options there to get our 99% CI. Here's the result that we get. Remember, we're using z-stats, not t-stats. So our lower and upper limit are what you see here. There's our 95% confidence interval for the mean brain volume based on our sample. Given that typical brain volume values are between 950 and 1800, do these values from our 99% CI appear typical? Well, notice that the entirety of the CI is within that range of typical values. So therefore the answer to this question would be yes, because our entire CI is within that range of typical values. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.